Well, g'day Year 7s. Okay, so today we're looking at something that's quite simple compared to the last few lessons. We're looking at something called the range. Now let's just quickly review what we've done over the last 3 lessons for statistics. Firstly, we learned how to calculate the mean, which is just a fancy word for calculating the average. Then we learned how to find the mode of a set of values, of a list of numbers, okay? And the mode is simply the number or the value that appears the most often in a list of values, okay? We say it has the highest frequency. And we learn how to calculate the median of a list of values, which really means the number in the middle once those numbers have been put into order, okay? So today we're calculating the range, which is probably the simplest of all of those, perhaps with the exception of the mode. That's pretty easy too. So what is the range? Well, the range of a set of values is the difference between the largest value and the smallest value. Done. It is that easy, okay? So we're going to do 2 extremely straightforward examples. Example number 1, find the range of the following values. So what we need to do is find the largest value and the smallest value. And if you're going to make a mistake, this is where you're going to make it, because you don't want to rush looking through the values. It's very easy to make a mistake at this point. So going from left to right, let me try and find the maximum value. Whoop, there it is, 67. And what about the minimum value? Let's see. Oh, right next to it, 10. Okay, so here's the formula. Range equals maximum value minus minimum value. Couldn't get much easier than this. Line up our equal signs. Well, the maximum value in this data is 67 minus the minimum value, which is 10, and that equals 57. So what is that good for? Well, the range tells us something about how spread out our data is. If the difference between the largest value, the maximum, and the smallest value, the minimum, is a small number, then we know that all of the values in our list of data must be pretty close together, okay? So the range, it's actually called a measure of spread. And in statistics, there are several different measures of spread, which just means several different special sorts of number that give us important information about how spread out a list of values are, okay? And this is the simplest, the range. All right, let's do a second example. So we have 11 runners. I've made a typo there. I should have an S after runner. 11 runners record their personal best times in seconds for the 100-meter sprint, okay? Here is the list. We've got a bunch of extremely good time. These guys must be Olympians, or at least people who are trying to qualify for the Olympics. Okay, so we've got a list of 11 100-meter times for 11 different people. Calculate the range from this set of data. Okay, so let's follow the same process. Let's identify the highest number, which is 10 seconds, 33 milliseconds, 10.33. That's still extremely fast. It's actually an Olympic qualifier. And the slowest time, the fastest time, where are we? Let's have a look. 9.7, oh, it's right next door again. 9:77. That's the fastest time. Okay, so what is the range? I'm going to write range equals worst time minus best time. Range equals worst time, which is still very fast, minus best time, which equals 10.33 seconds minus 9.77 seconds, which equals 0.57, and don't forget the units, seconds. This is a real-world question. We're dealing with seconds, so our answer to the question needs units. You need to write seconds there. So what does that tell us? Well, the range is a pretty small number, which tells us that if the difference between the fastest athlete out of those 11 and the slowest athlete out of those 11 is only 0.57 seconds, then even if we didn't have that list of data in front of us, we'd be able to say that all of those 11 athletes are all pretty much as fast as one another, because 0.57 seconds is not a lot. But if the range was, say, I don't know, 5 seconds, then we'd be able to make the conclusion that the difference between the fastest athlete and the slowest athlete was large, okay? And from that, we could probably start to make all sorts of other assumptions. Maybe some of the athletes were juniors and that sort of thing, okay? All right, quick one today, guys. Thanks for tuning in. I'll see you next time.